Today we are going to discuss how to build multi-regional monitoring based on Prometheus. Hey, what's up everybody? Welcome back to my channel. My name is Aleš Nosek and I am the software practitioner located in San Diego, California, helping you navigate the world of Kubernetes. Recently, I was working for a customer that utilized data centers all over the world. They were deploying into private data centers as well as public clouds. My task was to create a Prometheus-based monitoring system that would monitor their services in all of the regions. This customer was using Red Hat ACM to manage their OpenShift and Kubernetes clusters. So I looked into how Red Hat ACM implemented observability of clusters. I discovered that Red Hat ACM uses an open source project called Observatorium and decided to use Observatorium as the basis of the new custom monitoring system. You can find Observatorium project hosted on GitHub. You can find it at github.com/observatorium. Observatorium comes with an operator, which allows you to deploy Observatorium components on Kubernetes or OpenShift. And the operator comes with documentation, which guides you through the deployment process. Currently, Observatorium is not available through OLM on OpenShift. That means that you will need to deploy the operator manually. Now, based on these deployment instructions, I created a separate GitHub repository called Multi-Regional Monitoring using Observatorium. And I'm using this repository throughout the video, and I'm using it to deploy Observatorium as well as deploy Prometheus and Grafana. The links to both repositories, I will include them down below the video. Before we get to the deployment part of our video, let's review the architecture first. In this diagram, I'm showing Observatorium deployed to an OpenShift cluster. You can see that at the front of the deployment, there is an Observatorium API component. This component is a facade which exposes Prometheus APIs to the public internet. Observatorium API component ensures that the requests coming to the APIs are authenticated and authorized. The two Prometheus APIs which are exposed are the Prometheus Remote Write API. So this allows you to send your Prometheus metrics from the Prometheus server using the remote write protocol to Observatorium. And the second API is the Prometheus Query API, which allows you to, for example, connect Grafana to Observatorium to read the metrics out and show them in the graphs. Observatorium itself does not implement Prometheus APIs. Instead, Observatorium deploys components of the Thanos project, and Thanos is the one who actually handles the metric writes and the queries. The metric writes are handled by Thanos, and eventually all the metrics will, for the long term, be stored on an S3 compatible storage. So that is a very efficient solution how to store metrics for the long term. Also, Thanos is a highly available system. In this diagram, I'm not showing it. However, each of the Thanos components comes deployed as 2 or 3 replicas to ensure high availability. And also, of course, I assume that this cluster itself is highly available. It means the OpenShift cluster. That means that the OpenShift cluster is deployed across at least 3 different availability zones. Let's now discuss how metrics are ingested into Observatorium. First, you configure your Prometheus server to send the metrics to a remote write endpoint, which is the Observatorium API. Prometheus now is sending the metrics in the real time to Observatorium. Observatorium will route the metrics through the Observatorium API to the Thanos receive component. Thanos receive is collecting the metrics, and every 2 hours, Thanos receive creates a block of metrics and writes it into the S3 storage. An independent process called Thanos compact reads the blocks from the S3 storage and compacts them, and then writes them back to S3 storage again. And the goal of compaction here is to further reduce the storage capacity required to store the metric blocks. In addition to that, Thanos compact also downsamples the old metrics. It means it will remove some of the old historical samples altogether, so that the storage needed to store the metrics is again reduced. However, in the old historical data, there is still enough samples available so that you can see the historical trends in your graphs. Let's now discuss how metrics querying is performed. For that, you point your Grafana instance to the data source, which is a Prometheus query API. This API is exposed by the Observatorium API. Now, after Grafana sends a query, Observatorium API will route that query to the Thanos query frontend component. The Thanos query frontend is a component which improves the query performance. It caches the results of previous queries in memcached. And in the case that the current query is retrieving the same data as the previous ones, it can just return that data to the client from cache. After the query request passes through the caching layer, it will arrive at the Thanos query component. Thanos query is a component which actually processes the query request. And in order to evaluate the query, Thanos query component needs to fetch the metrics data. This metrics data is available in 3 different locations. For the recent metrics, which are not older than 2 hours, Thanos query will reach out to Thanos receive. If the metrics are already older than 2 hours, then they have been already put into a block and uploaded into S3. So that's where Thanos query needs to pull them from. Thanos query doesn't go to S3 directly though. Instead, Thanos query makes a call to Thanos store component, and Thanos store will actually do the fetching from the S3 bucket. Now, the function of Thanos store is abstracting away the particular bucket provider in use. In our case, we are using S3. However, Thanos supports other bucket providers. And so Thanos query doesn't need to know about that detail because it just uses the API provided by Thanos store. Also, Thanos store speeds up the retrieval of metrics because it creates a index cache in its memcached. So the long-term metrics are fetched by Thanos query, and that's the second place where the metrics come from. Last location where Thanos query looks for metrics is the Thanos rule component. Thanos rule is the component which evaluates recording rules. Thanos allows you to define recording rules similar as the Prometheus server. And so these recording rules produce additional metrics. And so if the query requires to fetch those metrics, then Thanos query will reach out for them to the Thanos rule component. So at this point, Thanos query fetched all the metrics required to evaluate the query. And after the query result is computed, Thanos query will send it back through the caching layer back to the client, which is Grafana. I didn't mention one more function of the Thanos rule component. Thanos rule also evaluates alerting rules. It does it by constructing respective Prometheus queries, which Thanos rule will ask Thanos query to evaluate. In the case that the result of the query triggers an alert, then Thanos rule will contact Prometheus Alert Manager to send out alert notification. So now that we have a good understanding of how Observatorium handles metrics, let's take a look at how we are leveraging Observatorium to monitor our region. In this diagram, I'm depicting one of our regions, US East 2. That one is located in US, Ohio. And as you can see, we deploy one highly available Observatorium instance per region. And then within the region, we have several Prometheus servers scraping metrics. And it can be Prometheus servers, which are deployed on the same OpenShift cluster as Observatorium itself. We have Prometheus servers deployed on other Kubernetes and OpenShift clusters, and we have also Prometheus deployed on virtual machines. So from wherever the Prometheus in the region is deployed, it can push the metrics using the remote write into our Observatorium. In order to prevent metrics loss, in the case that the Prometheus server is down, we follow best practices and always deploy Prometheus servers as a pair. So in the case that one of them is not available, the other Prometheus server can still scrape the metrics and send them to Observatorium. In the case that both Prometheus servers are up and running, which is the normal scenario, we deduplicate the metrics in Observatorium. Thanos components can do the deduplication. The remote write functionality in Prometheus reads the metrics from the write-ahead log in the Prometheus server, and this log contains at least the last 2 hours of metrics. That means that in the case that the Prometheus server would not be able to reach the Observatorium endpoint, then it will still be able to send the metrics later when the endpoint becomes available, and the endpoint can be gone for up to 2 hours and we will still not drop any metric which was scraped by Prometheus. As you can see in the diagram, metrics scraped in the region will stay in the region. We do not send metrics out of the region for storage. We always store them in the same region as we scrape them. And the reasons are, number one, that sending gigabytes and terabytes of metric data out of the region would be costly. And number two, path between scraping the metric all the way to the final storage place would be also longer and hence less reliable. Regarding the evaluation of alerting rules, there are really two options. We can have the Thanos rule component, which is sitting somewhere here in Observatorium. We can have Thanos rule evaluate the alerting rules, and in the case that alert fires, that component would then contact the alert manager. Or we can have individual Prometheus servers directly evaluate the alerting rules, and in the case that the alert fires, the Prometheus server would then contact the alert manager. So what are the pros and cons of the two options? Let's discuss the Thanos rule option first. There's several things which need to happen before Thanos rule component can mark the alert as firing. So after the Prometheus server scrapes the metric, it will push the metrics through the Observatorium API all the way to the Thanos receive. And after that, Thanos rule, which is periodically evaluating the alerting rules, will send a query to Thanos query component, which will in turn fetch those metrics from Thanos receive and compute the result of the query and then send the result back to Thanos rule. Only based on this result, the Thanos rule can recognize that the alert is actually firing. To achieve reliable alerts, we would like to have the alert evaluation path as simple as possible. In regards to the Thanos rule option, the path is a little bit more complex. However, there are benefits to using Thanos rules. Benefit number one is that Thanos rule has access to the Prometheus metrics from all the Prometheus instances in the region. So that allows us to create alerting rules which go across the Prometheus instances. Benefit number two is that the rules with the Thanos rule can be managed pretty much in one place, which makes it then easier to manage them. If we, on the other hand, consider the option of evaluating alerting rules in the Prometheus server, then what we get is a much simpler evaluation path. Directly after the Prometheus scrapes the metrics, it can already evaluate the alerting rules in the very same process. So that's nice. On the other hand, Prometheus server has only access to the metrics which it itself scrapes. And also we would need to somehow distribute the alerting rules to all of the Prometheus instances. So that makes it a for a little bit more complexity for managing it. And the last component I wanted to talk about in this diagram is Grafana. We configure Grafana with a data source of type Prometheus, which we then point to the Observatorium API. So that's how Grafana can now fetch the metrics which were scraped in the local region and show them in the graphs. However, we wanted to go one step further. We wanted to see also in the same Grafana instance, we would like to also see not only the metrics from the local region, but also the metrics from all the other regions as well. How can this be accomplished? And the approach to that is depicted in this diagram. I'm showing here 3 of our regions. A region located in Frankfurt, Germany, then Ohio, US, already mentioned before, and one more region in Singapore. As you can see, we deploy Grafana in the region, and Grafana is pointed to local observatorium to be able to display the metrics scraped in the local region. But on top of that, we also create additional data sources in Grafana, and we create one more data source for each of the other regions. So that allows Grafana to reach out to the other regions and bring the metrics from there as well, and show them in a one Grafana instance metrics from all the regions. You can see that we are deploying Grafana the same way in all of our regions, so that the overall deployment is perfectly symmetrical. Currently, I have the 2 regions already deployed. So in the remainder of this video, I'm going to deploy the last region, deploy the Observatorium and Grafana and Prometheus in that region. And then I'm going to show you how Grafana can display the metrics from all of the regions in one Grafana instance. So here we go with the deployment. I am logged into OpenShift in the US East 2 region. And also I have my Git repository, multi-regional monitoring using Observatorium checked out. So first thing, we are going to create a namespace where we are going to deploy all the components. That namespace will be called Observatorium. So I will do oc apply -k Observatorium namespace. So as a next step, we are also going to deploy S3 compatible storage. That storage will be used as a long-term storage for the metrics which are collected in this region. So I'm using MinIO project as a S3 compatible storage. So I will deploy it right now. MinIO. And after that, we can already deploy the Observatorium Operator. And that one will take a while to deploy. All right, the operator is starting up. And before we can deploy the Observatorium instance, I think we should talk about the authentication and authorization settings in Observatorium, which we will need to figure out first. Regarding authentication, the Observatorium server authenticates itself to the client using its server TLS certificate. That is the typical way how servers do it. On the other hand, client has 2 different options for authentication to the server. Option number 1 is using client TLS certificate, so that will give you mutual TLS authentication. Or the second option is the client can participate in the OIDC or OpenID Connect flow and authenticate itself using an OIDC token. As our 2 clients are Prometheus and Grafana, it is easier to use the mutual TLS authentication because you can directly configure Prometheus and Grafana to use the TLS client certificate. In the case that you are in a situation where mutual TLS won't work for you, maybe because You have a reverse proxy in front of Observatorium, which needs to terminate the TLS connection in order to inspect the traffic. In that case, you will prefer the OpenID Connect token authentication. If you choose to use mutual TLS as your authentication method, I created a set of instructions for you showing how to generate the required TLS certificates. What you will need is first a root CA certificate, and then from there you can generate 3 leaf certificates. The first is the server certificate, which will be used for your Observatorium API endpoint. And then there are 2 client certificates, one certificate for Prometheus and one certificate for Grafana. What is important to notice on these certificates is the subject and the subject alternative name settings. So I'm setting here the subject alternative name DNS to Prometheus 1. So this directly maps to the username in Observatorium. And also I'm setting the subject organizational unit part to Prometheus's, and the organizational unit in Observatorium maps directly to groups. So in other words, when Observatorium sees this certificate from the client, it will know that the client user is called Prometheus 1 and that user belongs to the group Prometheus's. A similar way it is done for the Grafana certificate as well. You can see that the Grafana is sending a cert which will identify Grafana as user Grafana1 and that user belongs to the group Grafanas. If you, instead of using client certificates for the client authentication, if you instead prefer using OIDC tokens, then Observatorium project comes with a set of instructions showing how to set up a OpenID Connect client credentials flow with Observatorium, and I will also include the link to these instructions down below the video. In a nutshell, these instructions will use OIDC provider Hydra, which you can install yourself. And this OIDC provider is configured with one client, with the client ID user and client secret. And this client will be participating in a client credentials OIDC flow. So with this flow, after the client authenticates itself against the OIDC provider, it will immediately receive a valid token. Unfortunately, Prometheus doesn't really support the OIDC client credentials flow, so it cannot really do the exchange of credentials for the token by itself. So instead, this set of credentials suggest using a proxy which is called token refresher. And the token refresher proxy is configured with that set of client credentials, so that now that this proxy can authenticate against the OIDC provider and grab a fresh token or refresh a token. So when we have this nice proxy now, instead of Prometheus sending the metrics directly to Observatorium API, instead Prometheus will send its request through this proxy, so that this proxy can attach a valid token to the authorization HTTP header in this request, and then this proxy will forward the request to the Observatorium API. So now the request will come and includes the token, so that the Observatorium API can now authenticate the request. To get a detailed understanding of how authentication works in Observatorium, the best place to look at is the Observatorium API source code. I have it here, but you can also find it on GitHub under Observatorium/Observatorium. In the authentication directory here, you can find the implementation for both authentication methods, the mutual TLS as well as the OpenID Connect. One thing to also mention around the mutual TLS, one more detail, is the way how Observatorium determines the user from the client certificate which is incoming. So as you can see in this part of code, the Observatorium will inspect the subject alternative names in the certificate, and it will first look at the email addresses. If it is a array of email addresses, then it will consider only the first one as a username. If email addresses are not available in the cert, then it will go on and inspect URIs, or maybe there is DNS names. And as a last one, it will also consider the subject alternative name IP addresses. So that is how Observatorium figures out the client's username. And then after that also, it will need to figure out the group the user is in. And so for that, as I already talked about it before, it will look at the subject in the certificate, and in particular the organizational unit part, because the organizational unit is directly used as the group the user is in. Next thing to discuss is the authorization in Observatorium. And for that, I am back in my Git repository, multi-regional monitoring using Observatorium. And we can find the authorization configuration in the Observatorium instance configuration. So Observatorium is configured using a custom resource of kind Observatorium. And this custom resource configures all the components of Observatorium. So that also includes all the Thanos components. However, for us interesting is the API component. We already spoke about the authentication, so that one is configured here. Note that Observatorium is a multi-tenant system, so it even supports multiple tenants. However, I'm using only one tenant, which is called a default tenant. And in this tenant, I'm configuring the root CA, the one which I showed you before, so that all clients will be authenticated using this CA certificate. So when Grafana or Prometheus sends their cert, that one is signed by the root CA, so that's why they will pass the authentication check. And after the client is authenticated, the authorization part is configured here. So Observatorium is using RBAC to configure authorization. First, you define a set of roles. And I have here only two roles. So the first one is called read-only metrics. So that's a role which will be assigned to Grafana to be able to read metrics. And then I have a second role called write-only metrics. And this one will be assigned to Prometheus so that it is able to ingest metrics. And the assignment itself is happening here in under role bindings, where you can see that I have a role binding which to the subject, to the group called Grafanas. So all users in the group Grafanas will be assigned the role read-only metrics, and all users in group Prometheus will be assigned the write-only metrics role. So with that, we can now deploy Observatorium instance. And for that, we will do OC apply -k Observatorium instance. And I will deploy Observatorium only in the basic deployment. It means not highly available, but it will be enough for our POC here. All right, so deployment of Observatorium takes a while. You can see that, the containers are already deploying. So you can see the Observatorium API here. And then you can see the bunch of Thanos components, which we already talked about when reviewing the architecture diagram of Observatorium. Next, I will create a new console here. And we are going to also deploy Prometheus and Grafana into the same region. So OC apply -k Prometheus operator. So first we will deploy the Prometheus operator. And after that, we can deploy the Prometheus instance. We will need to use the customize. For some reason, the customize compiled into the OC client doesn't like my customized syntax. However, the newer customize is happy, so I need to customize build. Now I want to build the same, and now I will pipe it oc apply -f. We'll pipe it into the oc apply. So that will deploy the Prometheus instance. Next, we will also deploy the Grafana operator. So that's the Grafana operator. And as the last one, we will also deploy the Grafana instance. Okay, so as the services are now starting. Oh, that was quick. All right, so now we can start looking at how Grafana and Prometheus look like. To get access to the Prometheus UI, I will create a port forward here. And the port is Prometheus 0, and I would like to forward the port 9090. Now I can access Prometheus on the localhost port 9090. So let's take a look at the configuration of this Prometheus instance. As you can see here in the scrape configs, the Prometheus is configured to only scrape itself, so just scrape its own metrics and nothing else. This is good for the proof of concept. And then we have the remote write configuration here. So Prometheus is sending all the metrics to the Observatorium API endpoint. And in order to authenticate, it is using the certificate and the private key. And one more thing which is interesting in this config is maybe the external labels. When Prometheus is sending metrics out, it allows you to attach external labels. As you can see, the Prometheus operator already attached some of the labels for me. So for example, the designation of the Prometheus instance or logical instance is Observatorium Prometheus. So that's one of the labels attached. And then also there is a identification of the Prometheus replica attached as an external label. In this case, it is the Prometheus 0. If I would have a pair of Prometheuses, as I was discussing it before, then there will be a second replica, Prometheus 1. And based on this Prometheus replica external label, that's based on this also Thanos is able to recognize that there is one Prometheus but two replicas, and based on it, it is able to deduplicate the metrics. Now, as an additional external label, I configured myself this custom region label so that I have all the metrics also. I have a label attached to them from which region they were scraped. So let's briefly check that this Prometheus is collecting metrics. So for that, I will go back to the graph, and I can look at the scrape interval or scrape duration in seconds. Execute the graph, and we can see that it's been an hour since the Prometheus, at least an hour since the Prometheus is happily scraping metrics in this region. Next, let's take a look at the Grafana dashboard. So for that, let me get the Grafana route. I am logged into Grafana here, and we'll check the configuration of the data sources first. So you can see that this Grafana is indeed accessing metrics in all three of our regions. And if we take a look at the available dashboards, there is only one dashboard, which is the standard Prometheus 2.0 stats dashboard. I parameterized this dashboard so that we can change the data source, so that we can quickly flip between different regions. So here I'm seeing the metrics coming from the Singapore. However, I can also click and see how things are going in Frankfurt, Germany. And the last region is the Ohio, US region. So that's what I see here as well. Let's review what we covered in this video. We discussed the Observatorium architecture, and we have seen that in the Observatorium deployment, There is the Observatorium API component deployed at the front. Observatorium API takes care of the request authentication and authorization. The handling of Prometheus metrics is actually done by the Thanos components. And Thanos connects to a bucket provider in order to store the metrics for the long term. In our case, we were using an S3 compatible storage. We also connected Prometheus to Observatorium and pushed the metrics. And we connected Grafana to Observatorium so that we were able to see the metrics in the Grafana graphs. We discussed the regional monitoring setup, where you have seen that you can have multiple Prometheus instances within your region, or pushing data into the regional observatorium. And then we also discussed the multi-regional monitoring, where all the data scraped in the region stays in the same region. However, you can create a Grafana configuration where Grafana can show all the data from different regions in the one Grafana instance. Hope you enjoyed today's video. Please feel free to leave your questions or comments down below. If you found this video helpful, please consider subscribing so that you are notified whenever I release a new video. Until next time.